Welcome. I'm Srivardhan Reddy. I'll be presenting my final project presentation on intrusion detection system, and we'll also be discussing about the intrusion detection system using SNORT. In this presentation, we will explore what these intrusion detection systems are, the types, how they are configured, and types of protection they provide. And we'll also discuss about a popular IDS software called SNORT. What is an IDS? An intrusion detection system, or IDS, is any device or application that actively monitors your network for malicious activities and alerts you when it detects an attack. So why do you need IDS? No firewall is foolproof and no network is impenetrable. Attackers continuously develop new exploits and attack techniques designed to break your defenses. Many attacks leverage other malware or social engineering to obtain user credentials that grant them access to your network and data. An intrusion detection system is crucial for security because it enables you to detect and respond to malicious traffic. The primary benefit of an intrusion detection system is to ensure IT personnel is notified when an attack or network intrusion might be taking place. The network IDS monitors network traffic and triggers alerts when suspicious activity or known threats are detected, so IT personnel can examine more closely and take appropriate steps to block or stop an attack. Let's talk about types of IDS. While there are different IDS types and configurations, each one records information, notifies security administrators of unusual activities, and produces reports. Additionally, some IDSs can actually respond to and prevent attempted attacks. Most IDS softwares identifies threats using two common techniques, signatures and anomaly baselines. Here is a depiction of network and host-based IDS, which we'll be learning next. Just like any antivirus software, IDS software keeps a list of malware signatures. It compares incoming threats to this list and blocks any attack that's on the list. IDS software also monitors your system or network for any abnormalities. It locates abnormalities by establishing a system baseline and looking for variations from that baseline. No matter what type of IDS software you're using, you need to let it run on your computer so it can establish a normal range baseline. IDS software can be installed in a number of different configurations. Let's say you run a small B2B business. One common configuration is to place the IDS software before your firewall and your network. When it's on an individual workstation, it can detect any threat and immediately alert you. Because your business is small, a host-based IDS configuration works for your current network. One downside of individual hosting is it can slow down the computer, just like actively scanning antivirus software slows down other operations. IDS software can bog down individual machines. Now, let's talk about network intrusion detection system. Now, say you add a small boutique hotel to your business. You decide you need IDS protection, but don't want it to bog down your employees' computers. In this instance, you should install a switch between your firewall and your network, which allows you to install a dedicated IDS. The switch mirrors the data going to the workstation and send it to the IDS. This configuration protects your workstation, keeps them running a full processing speed, and keeps your employees and customers happy. Now let's look at SNORT. SNORT is an open source, rule-based network intrusion detection and prevention system. It was developed and still maintained by Martin Roche, open source contributors, and Cisco Talos team. SNORT is capable of analyzing live traffic, can detect an attack, has a packet logging feature, and can analyze a protocol, and can send alerts in real time. And SNORT also has a multiple modules and plugins to tweak, and it can work with Linux and Windows too. Now let's look at the Snort design. Snort has three main use models, and first one is sniffer mode, where it reads IP packet and prompt them in the console application. And the second one is packet logger mode, where it logs all the IP packets that are inbound and outbound that visit the network. And the third use model is NIDS, Network Intrusion Detection System, that logs or drops the packet that are, deemed as malicious according to the user defined rules. Now let's learn about some SNOT rules. Understanding the SNOT rule format is essential to understand its functionality and also to create new rules. So each rule should have a type of action, protocol, a source IP address, a destination IP address, and you know a source port and a destination port. Let's see a syntax of a SNOT rule. Like a SNOT rule has a header and it also has options. So first thing is actions. So there are several actions for a SNOT rule like alert, log, or drop or reject. So alert action generates alert and logs the packet. Log option logs the packet. And when you choose a drop action, it blocks and logs the packet. And likewise, so a protocol parameter identifies the type of protocol that filtered for the rule, like IP, TCP, UDP, or ICMP. And then the IP and port number parameters identify the source and destination IP addresses and associated port numbers filtered for that rule. So coming to the example in the slide, we can see that we used action type alert. So it alerts the administrator, and when ICMP protocol is invoked, so and we mentioned the source IP address and the source port, and it is given bidirectional. So when the ICMP packet flows from source to destination or from the destination to source IP addresses, so the message will be displayed that the ICMP packet is found. And here in the example we also mentioned a reference uh, of a known vulnerability, and also we can generate give a SID for it, which is a rule ID. So now that you have created a rule, it is a local rule, right? And it should be in the local rules file. So this is file is basically found under like in etc folder, under snort, and under rules section you'll find a local rules folder. So how does not work? So this diagram really explains what happens, right? So you have your network infrastructure, and then incoming traffic comes into the snort host or snort server, and then you can see right over here capture packets through sniffing. So it captures all the packets for all the devices or hosts on the network. It then goes through the preprocessor, and then it goes through the Snort plugins and packet decoding. And then, of course, it goes through the classification of the packets. And in the event of a signature, if it is matched, it alarms the alarm logging process, essentially implemented where it's either logged uh, or an alert is sent to the administrator. And it also goes through the snort detection engine and rule set, and again all comes into alarm logging process, or it in regards if how snort processes or essentially handles the traffic. And then of course again it goes to a log file for analysis. So as you know, like we have discussed, we have two use cases. One is where you can use snort as an intrusion prevention system. So you have your internet, and you have your router, and in some cases you may also have your firewall. Uh, so yeah, so to run Snort as an intrusion prevention system, so you place it in between your router uh, and the switch, so allowing the traffic to flow through the Snort. So right, so now that the snot can decide whether, like, based on the rules, Uh, if the rules are triggered, it can drop drop the packet. So basically preventing something malicious to pass through in the network or to a host. So it creates something like a choke point. Uh, Fairly simple, right? And the other use case is, as we were discussing, SNOT as an intrusion detection system. So a switch is placed, and whatever the traffic that is flowing to the system, whatever it is mirrored and send it to SNOT for analysis. So if the SNOT detects any kind of abnormality, signatures, or you know, if the rule says something is malicious, it's gonna alert and log it, or it's gonna simply log the file. And yeah, to conclude, in this presentation, we talked about intrusion detection systems and why do we need intrusion detection systems, and types of intrusion detection systems, how they work, and we also learned about a popular IDS in the market, SNOT. We discussed about its design, operation modes, and understood how a SNOT rule is and how to create a new SNOT rules, and also learned about how SNOT can work as IDS or IPS based on the network placement. And yeah, so SNOT is a powerful tool and it is considered as a superior network intrusion detection system when compared to most of the commercial systems out there. Yeah, so thank you for your attention. And while doing this presentation, I also learned a lot of things. It has been very resourceful for me, and hope I presented it well and you gain more knowledge on this topic. And thank you.